Okay, listen up, because right now, the clock is ticking and we are stepping directly into the exam room. Let's dive right into this explainer by stepping into the shoes of a top-tier, high-stakes barrister. Why? Because tackling the Cambridge Computer Science syllabus, specifically focusing on the 9618 Advanced Level Topic 6.2 on data integrity, requires exactly that kind of analytical courtroom mindset. You see, you aren't just writing down raw facts. You are building an undeniable, evidence-based case for the examiner. You are proving, beyond a shadow of a reasonable doubt, that you completely understand the nuances of data validation and verification. If you want to secure those absolute top marks, and I know you do, you need a bulletproof strategy. And honestly, this foundational logic doesn't just apply to 9618. This mindset stretches all the way across the board, from the foundational 0417, 0478, 0983, and 0984 syllabuses right through to 2210. I want you to picture two different students right now. Let's call them Alex and Sam. When Alex sees a question on data integrity, Alex just overloads the page with raw computer science facts, but includes zero actual analysis. On the other hand, Sam completely rushes, sweating the clock, and completely misses the specific command word requirements. They both leave the exam hall feeling confident, but when the results come out, it's a disaster. We're going to make sure you don't make their mistakes.
So, year after year, the Cambridge principal examiners report that data integrity, specifically data validation and data verification, is quite literally one of the most misunderstood and poorly executed areas in the entire computer science exam paper. Candidates just catastrophically drop marks here. But why is that? Is the core concept itself incredibly complex? Or is there a fundamental flaw in how candidates, like our friends Alex and Sam, are presenting their case? Well, we've analyzed the examiner reports, we've looked at the real past papers, and we're going to break down exactly what goes wrong and, more importantly, how you can flip the script and get it right. Alex loses marks because simply listing out terms like range check and presence check without connecting them to the scenario is like a lawyer just reading a list of laws without applying them to the client's actual case. Sam loses marks because rushing past the command word like confusing describe with evaluate means you are answering a question the examiner didn't even ask. It is completely crucial to understand that knowing the theory is only about 30% of the battle. The other 70% is entirely about execution.
Here is our legal brief for today's explainer. We're going to start with the examiner's verdict, then establish the core academic principles you need, outline the exact procedural framework, deeply explore evaluative thinking, and finally, close out with your complete winning exam strategy.
Let's move straight into Section 1. Examiners consistently, and I mean every single year, penalize students for three specific crimes on the paper. First, being too vague. Examiners want incredibly precise technical details. If you just say check the data, you are getting 0 marks. You need to tell them exactly how a length check operates on a specific string of characters. Second, forgetting to test your boundary conditions. Think about it. If a system is designed to accept values from 1 to 10, what happens when the user types in exactly 1 or exactly 10? What about 0 or 11? Those edge cases are exactly where your case falls apart if you ignore them. And third, dropping the specific context of the question scenario. This is Alex's biggest weakness. If the exam question is explicitly about a hospital database, your validation examples absolutely better be about patient IDs, blood types, or ward numbers, not some generic password login for a website. To beat this, you need to use the PEEL framework. Point, evidence, explanation, link. Make your point, give evidence from the scenario, explain how the validation works technically, and link it back to why it ensures data integrity. Now, before we continue to unpack this strategy, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. You do not want to miss the frameworks we are going to drop.
This quote brilliantly illustrates what I call the ultimate rule of law in computer science exams. This direct examiner alert highlights the method mark strategy. Listen, this means your procedural evidence, the steps you took to get to your answer, is just as important as your final verdict. This is exactly where our rushing student Sam loses an entire grade boundary. Sam just slaps down a final answer. But if your final output in a complex data verification trace table is slightly off because of a tiny math error under pressure, but you explicitly showed the logical steps of your double entry check or your parity byte calculation, those method marks can and absolutely will save your overall grade. Never, ever hide your reasoning from the examiner. Treat the examiner like they are a complete beginner. Walk them through every single step of your logic. If you calculate a check digit, write down the formula, show the multiplication, show the modulo arithmetic. Show it all. Moving on to Section 2. Let's establish the core academic principles. This comparison right here, this is everything. This is the difference between a B grade and an A star. The Cambridge Assessment Framework heavily prioritizes analytical depth, which you see on the right, over superficial breadth, which is on the left. This is the Alex trap. Simply dumping raw facts about validation types, like just listing out range, format, length, and check digits in a massive paragraph, will not work if you lack logical, structured reasoning. You need to use that Peel framework we just talked about. You need to explain why a specific check-digit algorithm is the absolute most robust choice for the given scenario, analyzing its effectiveness rather than just reciting its textbook definition. If the prompt asks for a validation method for a product barcode, don't just give me 3 random validation types. Give me the check digit, explain the mathematical algorithm behind it, give me the evidence of how it catches transposition errors, which are super common in barcodes, and link it back to the integrity of the store's inventory system. That is analytical depth. That is what we call the computer science success blueprint. You transform from a student reciting facts into a systems analyst solving a problem.
To build a truly bulletproof case in the exam hall, you absolutely must utilize cross-topic connections. The examiner reports are crystal clear on this point. Candidates who integrate precise definitions and causal relationships across the entire syllabus achieve significantly higher marks. They stand out from the crowd. For instance, when you're discussing data verification during data transmission, don't just keep it isolated to topic 6.2. Connect it back to network protocols, connect it to binary data structures, talk about how packet switching might introduce errors that necessitate a checksum. Show the examiner you understand how data integrity operates across the entire computing ecosystem. It's like a giant puzzle, and when you show how the networking piece connects to the data integrity piece, the examiner knows they are dealing with a top-tier candidate.
Okay, stop scrolling. Look right here. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students just like you improve by 2 to 3 entire grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Building your case requires consistency, so hit that button.
Welcome to Section 3. Let's break down the procedural framework.
Okay, this is your standardized sequence to secure every single method mark available. This is where we turn this explainer into an interactive workshop. Let's run a quick data scan challenge. Imagine a complex data table on your exam paper, showing customer records. Step 1. Identify the key data elements in the prompt. You have 60 seconds on the exam clock. Scan it. What's the core trend? Are the phone numbers inconsistent lengths? Are the dates formatted differently? Step 2. Apply the relevant theoretical principles. Is this a validation issue, meaning the data is unreasonable, or a verification issue, meaning it was copied wrong? Step 3. Execute your analysis with abundantly clear working. Step 4. Verify your results against the scenario parameters. And Step 5. Present your final answer in the exact format the command word demands. Remember Sam? Sam rushes and presents a description when the command word asked for an evaluation. Don't be Sam. If it says evaluate, you must weigh pros and cons. If it says describe, give characteristics. This 5-step process is your anchor. When the exam anxiety hits, you just fall back on your training. Identify, apply, execute, verify, present.
This builds right into what we call an algorithmic mindset. When facing a dense paragraph-long exam question, you must relentlessly deconstruct the prompt. Let's do a find the flaw challenge right now. Imagine a sample paragraph that says, to make sure the data is correct, we should use a length check on the name field. Can you spot the flaw? It's losing marks. Why? Because validation doesn't ensure data is correct. It only ensures it is reasonable. A length check won't stop me from entering Batman as my legal name. Extract only the relevant data points from the noise. Select your analytical framework, perhaps deciding between a visual check or a double entry verification method for a password reset screen. Finally, execute it using clear, unambiguous notation. Let's do a speed writing challenge. You have 30 seconds to mentally draft one perfect Peel paragraph on why a hash total is better than a simple control total. Go. Make your point, provide the evidence, explain the hash algorithm, and link it to data security. That right there is how you demonstrate high-level application skills.
Seriously, take 60 seconds right now to visually lock in this algorithmic thinking. Just look at the screen and let it sink in. Deconstruct, extract, select, execute. Ingrain this process into your memory. Visualize the timer counting down. It is the exact framework that will prevent you from missing critical steps or misreading command words when that intense exam pressure hits.
All right, Section 4, this is the pinnacle, evaluative thinking.
This is rule number 1 of our final system, command word decoding. When an exam question uses the command word compare, say comparing data validation and data verification, you must explicitly identify both the similarities and the differences. But here is the absolute secret weapon. You must deliberately use explicit comparative connectives. Words like whereas, conversely, on the other hand, or similarly. This explicitly flags to the examiner that you are actively comparing, not just writing two separate, isolated paragraphs. And you must support each side with hard, contextual evidence from the given scenario. If you just define validation, and then in the next paragraph define verification, you haven't compared anything, you've just stated facts. You need to say, both methods aim to maintain data integrity. However, whereas validation ensures the data is logically reasonable within system parameters, verification strictly ensures that the data entered perfectly matches the original source document. See the difference? That's a top-tier engine.
Top-scoring candidates act exactly like seasoned barristers during the closing argument here. When faced with an evaluate command word, they don't just present one single shiny idea. They consider multiple alternative solutions. They analyze the implementation trade-offs. For example, implementing a highly complex check-digit algorithm increases data integrity massively. Absolutely, but what's the trade-off? It might demand more processing overhead, slowing down a high-volume system. They openly acknowledge system limitations, recognizing and stating clearly that validation proves data is reasonable, but not necessarily accurate. And most importantly, the final nail in the coffin for securing those marks, they justify every single recommendation with undeniable scenario-based evidence. They don't just say this is best. They say this is best because, in the context of this high-speed banking system, the processing delay is acceptable, given the critical need for absolute financial accuracy.
Section 5. Let's bring it all together into the winning exam strategy.
Let's look at the complete computer science answering system. Implement these 3 fail-safes into your study routine immediately. Rule 1. Utilize memory hack acronyms to instantly recall all integrity factors and validation checks under exam pressure. When the clock is ticking, having an acronym for range, length, type, presence, format ensures you don't blank out. Rule 2. Relentlessly and explicitly check your boundary conditions. This is part of our time management matrix. Don't waste time testing 50 random numbers. Test the lower boundary, the upper boundary, one exactly inside and one exactly outside. Always explicitly show the examiner the exact boundary numbers you are testing in your exam booklet. Rule 3. Secure those method marks via clear working. Lay out every single step of your algorithmic decomposition to harvest all those crucial method marks, even if you stumble on the final calculation. Combine this with the Peel framework and flawless command word decoding, and you have built an unbreakable case.
We've seen the data, and it's incredible. Students who actively implement these specific data integrity frameworks, who decode the command words, who use the Peel structure, and who practice evaluative strategies, see an average improvement of 2 entire grade boundaries. But, and this is a big but, that only happens if they practice consistently with our weekly explainer breakdowns. You now have the absolute tools required to build an undeniable case, secure those marks, and leave the exam hall knowing you absolutely crushed it.
So here is your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. I want to hear from you. Drop a comment below with your target grade for computer science and the biggest challenge you're facing right now. Our team responds to every single comment. Like and share this video with a study partner. But before you go, I want to leave you with one final provocative thought. In an era where artificial intelligence is rapidly automating massive-scale data entry, will traditional validation methods become totally obsolete, or are they actually more legally and ethically necessary than ever before? Think like a barrister, build your case, and remember, ace the exams. Your Cambridge success starts here.